What's poppin', dogs? Mr. Allen here. We're about to match some quadratic functions in different forms to different graphs. Now notice the scaling on these graphs, there's none. Oh my goodness. So we're solely relying on whether or not my x and y intercepts are positive or negative values, and if my graph is concave up or concave down. So let's take a look at these forms because each one gives us something super duper easy. The first one here is called vertex form. Guess what it gives us? The vertex, dogs. I got to look inside here. That's my x coordinate, but I got to think opposite, -3. Outside gives me my y coordinate. It is 2. That one stays normal. So -3, 2. I'm looking in my second quadrant for my vertex. B and D both have a vertex in that second quadrant. -3, +2. -3, +2. So how do we differentiate between the two? Well, we got a negative out front here, meaning it's concave down. So it's got to be choice B here. F of x is choice B. Dope. Next one, g of x. That is factored form. So it gives me my x-intercepts super duper easy. -1, 0, and -5, 0 would be my x-intercepts. So if I'm looking for -1 and -5 on my x-axis, which one would do that? Also notice that it is positive out front, so it's concave up. So it can't be C. But if I look at A here, it could be crossing at -5 and at -1. Choice A will be my g of x here, right? It can't be D because D does not cross the x-axis, so there's no way I'd have two real solutions to it, right? So we're looking at our concavity, up or down, and then the easy feature. Let's continue on with h of x. This is standard form or general form, some will call it. All right. Now, the easy feature from that one would be my y-intercept, and here's why. If I plug in 0 for my x values, poof, they go away, right? Those first two terms go away, and I'm just left with 6. So my y-intercept has to be 0, 6, +6. And it's got to be concave down. Well, the only one that's concave down that's left is C. So you might be like, why are you going through all that stuff? What if there were more possibilities here, all right? Just trying to help you out, bro. Just trying to help you out. So h of x for C, and again, the reason being here, I have a +6 for my y-intercept. That's plausible there, and it's concave down. Dope. So obviously Q is going to be D, but why is it? Well, I have a positive y-intercept, right? That's 0, 8. When I plug in 0 for these, poof, they go away, and I'm left with 8. And it's positive out front there, so it's concave up. That matches both things with D here. And if I were to plug that bad boy into the quadratic formula and solve, I'd get imaginary solutions. And this guy's above my x-axis there, so I have two imaginary solutions. Q of x for this one here. Man, that was super duper awesome. So again, guys, look for your concavity if it's open up or down. That's a quick way to eliminate some of your choices. And then the easy feature, your vertex here, your x-intercepts here, and your y-intercept for those last two functions that we did. That's awesome. That's dope. I will see you dogs later. Deuces.